So as always, thank you everyone for joining. My name is Cody Armstrong, and today we're talking about creating surface models in Onshape. So the goal today is really to give you as much information as I can about surface modeling in Onshape, all the various tools that you'll need, the various curves that you're going to need, all the commands that really kind of wrap around that realm of surface modeling. As always say with these webinars, I really encourage you to ask any questions that you'd like. There's a questions section in the GoToWebinar control panel. Feel free to ask any question that you'd like in there, and I'll do my best to stop and answer the questions as we go through today's webinar. But again, the goal today, we're going to give you as much info as we can on all the various surfacing tools that we have in Onshape. So let's dig into it. Now, the agenda is pretty straightforward. I'm going to introduce you to some of the important surface modeling tools that you're going to need, and then we're going to discuss where they're used, where some common scenarios are where you might use some of these tools. And then, of course, I want to show you some examples of them being used. As always, again, feel free to ask any question, and I'll do my best to answer the questions as we go through things. So the agenda is pretty straightforward. It's really going to be a crash course in surface modeling, so let's jump into it. Now, if you're new to surface modeling, maybe you've been using solid modeling for a long time, but you're not really familiar with what surface modeling is, it's generally associated with more complex shapes, more advanced shapes. Some shapes that are difficult to create using extrude revolves and sweeps, at least by themselves. So they're generally a more advanced topic, more advanced technique than some of the solid modeling counterparts. Not always, but for the most part, it's more advanced, and it generally involves more complex contours. 3D curves being kind of the key foundation of a lot of these things. So organic shapes often don't have planar intersections and so they're more complex shapes, and the tools that you need to create those kinds of shapes are a little bit different. Now, the keys that I would stress to these kinds of shapes is they're a combination of first curves, then surfaces to create them. And the process of surface modeling is generally a bit different. Now, everybody kind of has their own approach to these kinds of things, but I think by and large, if you do a lot of surface modeling, a lot of times that kind of design work is done literally face by face. You're building faces of a model one at a time, maybe combinations at a time, but again, it's thought of in a face by face basis. The other example of surface modeling that I've seen quite often is what's called mixed modeling, where you use a combination of surface modeling and mixed, solid modeling to accomplish the goal. And ultimately, in the end, the goal is still to have a solid representation of the part when you're done. So we're going to discuss the process of enclosing or thickening your surface in order to get that solid. But in general, if we had to describe surface modeling, it's a technique used to create more advanced, complex shapes, organic shapes, that's using a combination of oftentimes 3D curves and surfaces. Now, what tools, what commands are you going to need to know to do these kinds of things? As I mentioned before, it's a lot of curves, and we're going to spend a lot of time today on curves for that reason. Curves are a very important part of constructing any of these tools, and curves are an important part of controlling the surface that you're trying to create. So bridging curve, projected curve, composite curve, 3D fit spline, all great examples of curves that will help you to create the shapes that you're looking for. And they're very easy to use. I'm going to show you examples of all of them in just a moment. But I think those are the foundations. So I want to stress that, oftentimes you're going to be creating these curves to set up the creation of a loft or a fill. So they're tools that help you to get the shape that you want for the surface that you will be creating. So they're prerequisites, so to speak, to that surface. Now, the last command I want to mention is enclose. Enclose will help you take that enclosed surface model and convert it to a solid. That's the command we have for converting to a solid. And the other one being thicken. It's not mentioned in that list, but it will allow you to take a surface and thicken it a given amount. So these are the tools that you'll need to create any kind of surface models in Onshape. Now, let's jump right into it with the curves. And I mentioned before, the curves are very much the foundation of these surfaces, so they're important prerequisite. We're going to go through them and a few examples of where you might use them. One of the most common is the bridging curve. Bridging curve allows you to create a curve that bridges two things. It could be two parts, like you can see in that screenshot there, and it allows you to create a curve that matches the surrounding geometry. And so the question then, if I'm designing, for instance, you can see in the screenshot that bike frame, it's really critical that the transition from the centerpiece of the bike frame to the seat post of the bike frame have a smooth transition. It can't have any abrupt changes in geometry, and that's where bridging curve really becomes valuable. It allows you to select two things and create a smooth curve that joins those two things, and that curve can then be used for guides in a loft or edges in a fill. They control the shape of the surface that's being created. Now, you have match position and match tangent. Match position will allow you to select 2 points and just create a simple straight curve between 2 points, but match tangent will allow you to actually match the surrounding geometry. So that's going to be the one, if you're really concerned about smooth curvature, that you'll want to use. So let me give you an example of this. Here we have the beginning of a bike frame, and you can see here I've got 2 curves coming out between the seat post and the center post here. So what I need to do, let's roll back to a point before those 2 curves. And we'll hide this sketch just to hide it. And what I want to do here is create a loft between these 2 surfaces, right? So using something like the loft command, I can select surface, right, and just select 2 edges of the model. What you'll find is I do get a loft. I get a lofted surface between those 2 edges, but it's a very abrupt surface. It's not a smooth transition in the shape, right? It's certainly not acceptable for something like a bike frame where you would be really concerned about the curvature. So this is an excellent example where bridging curve makes all the difference. By default, when I created this loft, I get this real sharp transition. What I can do to solve that problem is create bridging curves that function as guides in my loft, right? So I can select the bridging curve command, right here under the helix. You'll see in the drop-down bridging curve, and I select the 2 edges. In this case, an edge here and an edge here. Right? What you'll get is a curve that's tangent to both of those edges. That will give you the guide that will be driven in your loft, right? So there's the first one. I can control things, by the way, like magnitude or the bias, one side or the other. So I can control that if I'd like. I can grab it and drag it, or I can actually set values here. But that's really it. I hit the green check, and now I have a smooth curve that joins those 2 things, right? Those 2 parts in this example. And more importantly, I have a guide that it can be used in my loft to control that shape so that it's not a sharp transition. Now, of course, I'm going to need one more. You can see I have 2 edges here. And so I can go back to the bridging curve. Again, select my 2 sides. Right? Oh, forgive me. Easy mistake to make. Make sure to select second side, then click the edge. And there is my bridging curve. So I hit the green check. Now I have the appropriate curves that I can use for my loft. So I select loft, surface, and we'll create a new loft here to here with those as my guides. Right? Those bridging curves are now going to control that lofted shape. So that's a simple intro into the bridging curve. The neat thing about it is all you need to do is select, an edge on each thing that you want to create a curve between, and it will automatically make them tangent. So you have that smooth transition without a lot of effort. So that's the big thing with the bridging curve command. Like the name implies, it's really intended to bridge 2 different things, create a smooth transition between 2 different things. Very common scenario in surface modeling like this loft example. Now, they function equally as well as edges in a fill. So I'm showing you an example of a loft, but really fill works the same exact way. You could generate your bridging curves as edges in your fill and use them just as well. So just keep in mind, bridging curve has a lot of uses. This is just one example of that. All right, so I didn't mention it, but there's also a match position option in there. Match position will give you a straight curve between 2 points, a sharp transition. Now, match position, is very useful if all you need is a straight curve between 2 points. But match tangent will give you the smooth transition between the edges or things that you select. So match tangent is more common if you're concerned about the smooth transition of your loft, or constructing those guides for your loft or edges for your fill. So that is the bridging curve command. Let's move on to the next one, and that is the projected curve. So the projected curve creates a curve, a 3D curve, at the intersection of two sketches. And this was technically possible in the past, but it took what I would consider a lengthy workaround where you had to extrude two surfaces and split one with the other. So this is a very easy way to take two 2D sketches and find the 3D intersection of those sketches and create a 3D curve. That 3D curve can be used as a guide for your loft, an edge for your fill, very similar to the bridging curve. So let's get into an example of this. I'm going to jump out of this and jump into the toothbrush. And the example of the contour that I want to show you is something like this projected curve. You can see the outside contour of this toothbrush is a 3D curve, right? And to get that 3D curve, that's an important thing to start with. We used two sketches. So we'll roll back. Let's roll to that point. And you can see two sketches are visible here, right? On different planes. You can see they're perpendicular to one another. And what we want is the intersection of this curve and this curve. And if you think of this as I extrude this curve and I extrude this curve, and where they meet, that's your projected curve. So fairly straightforward. Again, you'll find it under the drop-down under Helix. You'll find the projected curve command, and all you do is select each sketch entity. Right? In this case, this spline and this spline. And what you'll get is a curve at the intersection of those two sketches. Right? That's what gives us that 3D contour for the outside of the toothbrush. Now you can use this as a guide for your loft, as was in this example, or an edge for your fill. It works equally well in both cases, but just keep in mind anytime you need a contour, an edge, so to speak, but that you want to maybe loft up to, or something like that, you can easily take two sketches, find the intersection, and you have that curve. So that's where a projected curve is really useful in scenarios like that. Again, where you're trying to control maybe the outside shape of something, but it's not two-dimensional, so to speak. It's a 3D curve that controls the outside shape. So that is projected curve. Again, the key thing there, just two sketches, and it finds the intersection and creates a curve at that intersection. Let's move on to the next example, and that is Composite Curve. Now, Composite Curve, initially when it was released, was a very important feature. But recent improvements to the Loft command have meant this command isn't nearly as valuable as it once was. Now, there are still scenarios where you might use Composite Curve, but I want to explain why this is not nearly as necessary as it once was. So if you've used Composite Curve in the past, just realize there's been improvements to Loft that allow you to select multiple things and define them as one entity and kind of simplify this process. Now, the idea behind Composite Curve is it's a composition of things that you select. And so you can make a single curve that is a combination of maybe a couple of edges and another curve and some random sketch geometry. And you could take all of these things, these random miscellaneous pieces of geometry, and make them into one selectable curve. Now, this had really great implications for things like guides in a loft. Because if you think about guides in a loft, I might want to, sketch a line, an arc, and that one combination of line, arc is going to be one guide. I could turn that into one composite curve and then use that in the loft command. And that's where it was used most of the time. And it was to take a combination of sketch geometry generally and convert it into a single curve that you could select in the loft command. Is of a few updates ago now, I think probably 2 months now, we've added the ability to select a combination of entities and turn them into one entity in the loft command, which kind of negates the need to do this. And I'll explain this in greater detail. There are still some applications for using Composite Curve, but I think the big ones aren't nearly as relevant as they once were. So let me explain. Here we have a handle of our spray nozzle, and what I want to do is I want to create a loft, but I only want to loft this, and this. These three edges to the other side, right? And if I go to, just the loft command, I select surface, and I just start selecting edges, what will happen is it assumes that I want to loft from this edge to this edge to that edge. It's not assuming that I'm trying to make up one big loft selection, right? So, of course, your loft is going to fail if you try to select multiple edges and loft between them. So, to accomplish this, to accomplish what I was trying to accomplish here, in the past, what I would do is create a composite curve. So I'd create a composite curve, select the edges, right? I can select here edge, 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 and now I have one curve that makes up those three edges. More importantly, I have one selectable entity when I go to do my loft, right? So I don't run into the issue that I ran into a moment ago. So I could do this. I could say loft surface and then select, two of these curves and loft between them. And it allowed me to kind of selectively define what it is that I want to loft by creating a curve first. So in scenarios like this where, I don't have one selectable entity to loft between, Composite Curve was the answer to that. Now I say was because that has changed. Let me describe what I would do today. So now I would no longer create composite curves. What I would do is choose loft and select surface, of course. Then select my profiles. The key is how you select the profiles. I'll select an edge, right? Then I'll expand the selection. This is what's new, is the ability to expand the selection and add to that one selection. So now I'm left clicking, and now I've added 3 edges to my one loft definition, right? My one loft profile. I could do the same thing over here. Left click a new edge, expand the selection, then select a couple more edges. Now I'm doing the same thing, right? I'm lofting now between these entities, as you can see here, but I didn't have to create the composite curve to do that. So I think that's the big thing I would stress. Now, there are other scenarios I could foresee where a composite curve would be useful. There are still areas where, if you find yourself selecting these same combinations of entities to do certain things, creating a composite curve still has an advantage. Just the ease of selection. But it's not a must for commands like loft anymore. As you can see, I can expand the selection, select more entities, and they will make up one profile for your loft. Or the same thing goes, by the way, for guides. You can select a number of entities as your guide and make up one guide. And that was another very common scenario that you would run into. You would have to create a composite curve to use a guide that consisted of more than one entity. Oftentimes it would be like lines and arcs and things, and you have to make a composite curve first. That's no longer necessary. In the loft command, again, the key is expanding those selections and then adding more edges to it. And the same goes for guides, by the way. If you choose guides, you can expand the selection and add more selections to make up one guide. So I hope that makes sense. Composite curve, again, still has its applications, but just nowhere near as necessary as it was when you had to use it for the loft command. Quick question. Can a composite curve... Can the composite curve be used as a source curve in a projected curve? I haven't tried, but I want to say the answer would be no. I think we filter by sketch entities, but I haven't tried to be 100% certain. I would have to try to be 100%, but I think not. Can a projected curve be used as part of a composite curve? Absolutely. Yes. So very good question. Can you take, any other curve, projected curve, bridging curve, any of those things, and add it to part of a composite curve? And the answer is yes. And that's one of the very good applications where maybe it's, a curve plus a few edges of the model or something to that effect. That's another example where you might use composite curve. All right, so let's move on. The next one in my list is 3D Fit Spline. And like the name implies, this allows you to create a 3D spline through selected points, through points that you select. I think the real value in this command, of course you can create a 3D spline through points, and that's rather simple, great, functionality, but the real power of this command comes in the ability to define a start and end direction, because that allows you to make sure that the 3D spline is a smooth transition from whatever geometry that you're selecting. So the example I have in the screenshot there is the spray nozzle. And you can see I want to create the bottom, rotated end piece of that handle to the spray nozzle. 3D Fit Spline is a great example of where to use that, because then I can say I want you to have a smooth transition from the edges of the handle. So again, 3D Fit Spline, if all you're looking for is a 3D curve through points, this is a great tool. But I think the real power of this tool is just the ability to select edges and say, make sure that you're tangent or you're creating a smooth transition from these edges. So let me give you an example of this. Let's jump back into that spray nozzle. And what I'd like to do is jump back to an example here. Right here. So we're going to roll back to this point in our design, and I just want to show this simple sketch. And what I want to create, that rounded bottom of the shape, is a 3D spline that passes through these 3 points, right? So through the 2 points of the handle, and this point that I've established is the very bottom of the handle. The important thing, however, isn't just that I get a 3D spline, but that spline is smooth transition from these edges. So I can select 3D Fit Spline under that same helix dropdown, choose my points, point, point, point. And you can see at first I do get a 3D spline, and if all you're looking for is a fit spline through 3D points or multiple points, you can keep going. This is it. But as I mentioned, the real power here, I think, is the ability to say, okay, here's the start direction, here's the end direction, right? And make sure that I have that smooth transition from that, right? Especially important in scenarios like this where, of course, I don't want an abrupt, transition to the bottom of my handle. So that's a simple example of 3D Fit Spline. If all you're looking for is a spline passing through points, it's a great tool, but it's also a great tool if you're looking for a smooth curve that matches surrounding geometry because of these options for start and end direction. You can also specify a magnitude, and that will allow you to control it. You can even grab and drag and control the magnitude here. And there is an option, by the way, for closed spline, if that's what you choose, if you're looking for a closed loop. So I hit the green check OK, and now I have my 3D Fit Spline. So let's move on. The next one in our list is the Loft command. Now this sounds obvious, of course. Loft is a very important command in creating surfaces, but in our case, Loft has a lot of functions that even in other CAD applications might be several different commands. So I do want to mention, you can define multiple edges in Loft, and you can say, I want these edges to be, continuous with others in Loft, and you could do all these kind of complex things inside of this simple Loft command. I think a lot of users overlook Loft and some of the capabilities that it has. So an example I've already given you when we were talking about bridging curve is, creating smooth transition between other lofted profiles. So in the example I gave you earlier, we created those bridging curves between the seat post and the top post of the bike frame, and I lofted between those edges with the bridging curves as guides to control that shape. That's an excellent example where the loft command is really valuable. We don't have dedicated special functions. It's simply an option of surface, loft, and select your edges. Right. The other one that I really like to mention is loft with path. This is oftentimes in other kind of applications a separate command or a sweep command or something to that effect. In Onshape, you have the ability to define two profiles for your lofted surface and then create that path based on a sketch entity. And that sketch entity will control the overall shape. And what's really unique is Onshape will automatically add these intermediate profiles between your selections. So you can see in the screenshot there, the top post of the bike frame was created using a loft with a path. And you can see those pink intermediate sections between the two lofted profiles controlled by, in this case, a spline joining the two. Now, very similar to like guides in a loft or sweep paths, you want to make sure that your curve is attached to both profiles of your loft, right? Either coincident or pierced, depending on the situation, but make sure that there is a constraint between the two. Now, we also have, of course, the ability to control with guides, and that's where you really get the utmost level of control in the shape that you're creating. So what I'd like to do is roll back a bit here, and let's take a look at creating a simple loft. Now, what I'd like to do, let's hide a surface here, right, is create a loft between these two profiles. You can see I have a series of edges here and a series of edges here. And what I want to do is loft these in two pieces with a path joining them. And you can see the path, if we edit this sketch, is just a simple spline. Right? It's a simple spline with some values defining the spline handles. So we could say loft surface. We'll create a new surface. And in this case, what I have really is 4 splines. And I'm only going to loft between half of them, as I mentioned. But here's another scenario where in the past, I would be forced to create a composite curve of these 2 splines if that's what I wanted to loft. Now I can select the profile, expand on the selection, and add another profile to it to make up one lofted profile entity, right? So same thing over here. My second one's going to be this spline plus, again, expand the selection, second half, right? So there is our initial lofted shape. What I wanted to add is the path, and we can select the path here, and you can see now the loft will follow that path, and that path is just a single spline right through the middle of it. So that is the option for path. It's one of my personal favorite options in the loft command. Again, I think, if you've come from other kind of applications, this has been in other places, but it essentially allows you to take 2 profiles and tell them to follow this path from point A to point B. If I uncheck to give you an idea of what it looked like before, it was just a sharp transition from point to point. Of course, that's what you would expect in the case of 2 parallel planes. But in this example, adding that path allows me to control that shape with something like a spline. So that's one more example of the loft command. I know I've already shown you an example of where guides can really make a difference. That's where, again, bridging curves or any kind of curves are really going to be the key to how smooth your surfaces are. Right? So that is loft. The big thing I would stress about loft is it's very much a tool that can be used in a lot of different situations when we talk about surface modeling and Onshape. So there's a lot of situations where I could use loft, or it might be combinations of other commands, in past CAD systems. All right, moving on. Now we get into the fill command. Now the fill command is the command that allows you to essentially take a combination of edges and patch them with a surface, create a surface that fills those edges. Now, That's simple enough to do. Of course, you create the edge, you define all the edges that make up some kind of a boundary, and it creates a surface. The power of this command is the ability to define continuity for each one of those edges. So the ability to say, I want the surface to have a tangent transition from the edge that I selected. And I can go through and ensure that at points that are really critical, I can have a smooth transition between the shapes. So again, it simply creates a surface that fills a combination of edges that you select. Those combination of edges must create a closed boundary, of course, for it to create that filled surface. The other thing I always like to mention about this is this command. If what you're doing is creating the final surface in your model to close everything up, it will automatically fill the model and create a solid. So one of the neat things about this command is, as you're going through in surface modeling, if one of the last things you do is fill, it will automatically convert to solid if it can. And the reason this is important, I think one very common workflow is importing models from other CAD systems and then maybe having to delete a couple of faces to fix them and then filling them using the fill command to fill those faces back in. And if you do that, it will automatically convert once you've created that enclosed solid, right? So that enclosed volume is really the key. All right, so let's get into the fill command. And so for this, I have this ice axe example. And you can see this is built using surface modeling. And I still have one open surface to create here. And you can see it's just a combination of edges that make up this ice axe. Now, you'll find the fill command under offset. You'll see it right here. And it's just a matter of selecting edges. So I just select the edges that make up the boundary that I want to control the fill. Right? So I'm just going through and selecting all of these edges. And once I create that boundary that's enclosed, you can see I've selected that last edge. It automatically encloses it with the fill command. You can see there is our fill. Now, I mentioned before that's rather easy to do, just create that simple surface. But the important thing here is that I need to be able to control what this transition looks like. You can see here the transition from the handle into this surface that I'm creating is very sharp and not ideal. What I would really want is a smooth transition from this edge into my new surface. So what I need to do is find that edge, right? I can find these edges and define them as tangency. You can see in the drop down, I have the option to define tangency or curvature. Curvature if you're looking for curvature continuous transitions rather than simple tangent transitions. But again, the key here is I'm going through edge by edge and every edge that I've selected in my fill, and I'm saying these are the edges where a smooth transition, tangency or curvature, is really important. Right? And so you can see now I have a far smoother transition from the handle of my ice axe into the actual head. Right? So that's an example of the fill command. It really takes an open surface and it will patch in a surface to fill that. Even if this is a scenario where Loft really isn't useful because I need many different edges. It could be a combination of 8-10 edges and even more. And so just keep in mind, fill is really an essential tool in those kinds of scenarios. There's not much else that will replace it. All right, so that is the fill command. Let's move on here to enclose. Now, up to this point, we've been talking about surface models 100%. Everything that I've done up to this point has been surfaces we've been creating, not solid geometry. Inevitably, though, you'll want to take what is a finished model and create a solid out of it. That's the goal even of surface modeling today, is to finish with some kind of a solid shape. It's just a tool in helping you get there. And we have two ways to take a surface and convert it to a solid. We have a thicken command, which will take a surface and just offset it, give you a solid. And we have enclose. Enclose will take an enclosed volume consisting of planes or surfaces and make a solid out of that enclosed volume. So it depends on the scenario. If all you're trying to do is offset your surface a small amount, it's thicken. If you're trying to take an enclosed volume of surface, your model creates an enclosed volume and you're ready to convert it, then it's enclose, right? Quick question, can you prevent the fill command from creating a solid? No, there's no way that I know of to deliberately stop it. If it's not enclosed, if it doesn't see an enclosed volume, it won't do that. But if it's enclosed, it will automatically fill, and there's no way to say don't do that. You could go back with a delete face. I know that may not sound like the most ideal solution, but delete face, leave open will allow you to just delete one face and go back to a surface model. But yeah, there's no way that I know of to tell it don't enclose. All right, so enclose command, rather straightforward to use. The thing that I would mention here is generally this is probably one of the last commands that you're going to do to a surface model because you're taking it and converting it to a solid. Now, you can go back and forth, as I mentioned just a moment ago, a delete face. You could do a delete face, leave something open that will convert a solid into a surface, so you can go back to treating it like a surface model. So it's not written in stone once you go back and forth between the two. But generally, this is one of the last steps that you're going to do after you've finished much of the surface modeling. Now, I do want to point out, you don't necessarily have to have one surface that makes up an enclosed volume. It can be a composition of things. It can be, this surface plus this face plus this plane even. So it could be a combination of different things, as long as those different things make up one enclosed volume, as long as they create a boundary for the entire thing. So I know, as a rule, you may come in and enclose this surface on the bottom of my steam iron here with something like a fill. And you can do that. There's no rule that says you can't, but you don't have to if all you're trying to do is enclose, because I have a plane here. I have this plane, and I can use that plane as definition for my enclose. So a tip, you don't necessarily have to go through all the effort. I know there are many users who still will. They will still create the fill surface here and the fill surface here, and they'll make sure they have one enclosed surface, and that's fine. But you don't have to. I can go to the enclose command. You can see it just to the right of Loft under thicken. You'll see enclose, and you can select a combination of entities that make up an enclosed volume. So I can select this surface plus, this surface plus this plane plus, this plane over here, even though they're open technically, and it will find that that's still an enclosed volume and create a solid model out of it. So there's my solid enclosed. Let's do a quick section view here just to prove it. There's my sectioned steam iron solid, right? So again, if you want to go through the effort of patching those surfaces in with the fill command and then doing your enclosed, that works just fine too. But in this case, you can see I chose a combination of a couple different surfaces and two different planes, and it works just fine. Question, can I import a Modo surface model and create a solid? Well, that all depends on the format. I don't remember if Modo specifically is on the list. I don't think so, but I can double check at the end here, so bear with me. But if you can export to a format like Parasolid or Step or IGES or one of those formats and import, yes. So I can get into the list of translated formats in just a bit. I'm not certain we can import Modo native, but if they can translate, maybe. So forgive me, not 100% certain. All right, so that is the enclose command. Now, the other thing that I didn't mention is the thicken command, and that will simply take your surface and offset it and give you a thickened version of it. That's, of course, a solid model. Very easy to use. You select your surface, you select your faces to thicken, and the directions you want to thicken them. You can go in multiple directions if you choose to. So that is what I had planned for you. I am going to stick around and answer any questions that you have. So make sure to ask them in the questions section there in the GoToWebinar control panel. I will do my best to stick around, make sure they all get addressed. One final thing I wanted to mention is if you haven't already, definitely check out the Onshape Learning Center. We have instructor-led training there. We have self-paced training, technical briefings, lots of great training content if you're interested in learning more. Great place for all things training. So that is what I had planned. Again, I'm going to stick around and answer any questions that you have. So just bear with me. But that's it, everyone. Thank you and have a good day.